Okay, so if you want some help on these 12 problems or how to do them, I'm going to go ahead and do these 12 problems as kind of like an example / reminder of everything. All right, so first you have to remember that you want to check for a greatest common factor. So when you check for a greatest common factor, you're looking at all the parts and you're asking yourself, do they have any factors in common? So like x squared, 3x, and 18 don't. But like over here, I noticed that 5 goes into all these coefficients, and the letter k is involved. So I'm going to be taking out a 5 and a k. All right, so let's get started with number 1. So number 1, I notice it's a trinomial. So what I'm doing is I'm trying to think of numbers that multiply to 18. It's a very simple one because there's nothing in front of the x squared but a 1. So 18 is 9 and 2, we got 6 and 3, and of course 18 and 1. So with here, I'm just trying to think, which of these could make my 3 as well, because I know they make 18. So I'm going to choose 6 and 3. So I got x and 6 and x and 3. I don't put any signs yet because I'm thinking to myself, this makes 3x, this makes 6x, and I want this to end up to be a negative 3x. So I want a negative 6 and a plus 3. So that's how I know to put a negative here and a plus there. All right, over here, like I mentioned earlier, we're going to go ahead and take out a 5k because I don't even look at this yet because I notice they all divide by 5k. So 5k goes here, 5k goes there. So you can do this to help yourself out. And when you're writing your answer then, you're going to say, oh, 5k comes out. Oops. So that leaves me with k squared plus 2k minus 15. All right, and so you can either divide these in your head, or you can ask yourself, 5k times what makes 5k to the third? And then 5k times what makes 10k squared? You can do reverse distribution basically. All right, so now we're back in the same place. I got the 5k out here, has to stay. What multiplies 15 and makes 2? I'm going to go ahead and say 5 and 3. And I want a plus 5 and a minus 3 to make the positive 2. All right, on number 3, they do have a GCF. They both divide by 4, and I can take an n squared out. So I'm taking a 4n squared out. So 4 times 1 makes 4 again, and then I need an n squared times an n to make the n to the third. So I'm just thinking about what times what makes this 4 into the third. So and then 4 times 5 would make 20, and the n squared is already there, so I'm all set. And this is a simple linear factor. This n doesn't have a power on it, or it has a power 1, so I'm done with my factoring. With number 4, I notice I have a 2 in common, so I'm going to take that out first. M squared minus 16. And now I notice I have the difference of squares. So notice I have the difference, so subtraction, and I have perfect squares right here. So I'm going to go ahead and factor that. Get m plus 4 and an m minus 4. Okay. All right, now number 5. So number 5, this is probably the hardest one we've done so far because none of these have anything in common. I have a 3 in front that I can't take out in any other way. So I'm stuck just putting it as 3b. And b. So now look, I'm still trying to think of things that make 15, but no longer are the things that are making 15 are also going to make the 4 in the middle. So I'm just stuck kind of guessing and checking. So let's try some. So 15, 5 and 3. So look, I can't put the 3 here and the 5 there because 3 goes into 3 and these are not supposed to have anything in common. So that means the 5 would have to go here and the 3 there if I'm using 5 and 3. So let's check it out. It's making 9b and 5b. Well, 9 and 5 can subtract to 4. So I think I found it. So I want 3 here and 5 there. So that's my 9b. This is my 5b. So that way if I do plus 9 minus 5, it makes this 4 here. So minus and a plus, and I'm done. All right, same approach here. 2, 3, and 14 have nothing in common. No v's across the whole thing. So I'm getting 2v and v. Let's try 14 for 7 and 2. So again, I'm not going to put the 2 in the front parentheses because 2 goes into 2. So I'll try the 7 there and the 2 there. Then I'm going to say to myself 4v and 7v. Well, these can make -3 if I make a -7 and a +4. So negative and a plus. And then I do one last check to make sure I haven't ruined it. -7 times 2 is -14, so that checks out. And back here, -5 times 3 is -15, so that checks out. So you gotta, sometimes you might trick yourself and like these things make the -3, but then for some reason you lose the -14, but that didn't happen. All right, so same thing here, no GCF, 2x and x. And so now I'm just guessing and testing because, there's no reason not to put the 3 here and the 1 there, or the 1 here and the 3 there to make this 3, like, I don't know. So I think I will try, if I do 3 here and 1 there, that makes a 2x and a 3x. So you see how those could never make my 7, right? So I know it's going to be a 3 here and a 1 here. This is a 6x and a 1x, which if they're both negative, make my -7. Then do your one last check. -1 times -3 makes +3, and we're good. All right, for number 8, I got 5a and a, no GCF. For 6, I have a couple options, 3 and 2, 6 and 1. So let's do here. As you get better at it, you start to realize hey, if I use 6 and 1, the 1's here and the 6 there, that's going to be 30. That's way too big to go make 1 right here, so I'm not going to use that. Maybe I do my 2 here and a 3 there. So that's 15 and 2. That doesn't make that. All right, so maybe I put 3 here and 2 there. So it's 10 and 3. 10 and 3 doesn't work either to make this 1a. So what I never did try was 6 here and a 1 there. That's 5a and 6a. That can make my 1 right there. All right, so what did I say? 6 here and 1 there. So my 5a and my 6a, that would be a +6 minus 5 to make the 1a. Okay. All right, let's see, 3, 17, and 20, nothing in common. So again, 3v and v. And also as you start to get better at it, you start to notice some things. If the end is a positive, that means that you're going to have the same sign. See, let's see, I don't have any others right here. So this one right here, the end is a positive, so I'm going to have the same sign, and this tells me what it is. I'm going to have double negative. So sometimes you can start putting in signs, like this is a positive, and that's a positive. So when I write this problem, it's going to have 2 positives. So that's the only time you can put in your signs, because if the end is negative, this plus and minus you have to figure out which way it goes. So I just like to leave the signs to the last, no matter what. All right, so the 20, let's see on the end. So, I don't know, 5 and 4. I think if I put 5 here and 4 there, let's check that out. Yep, I got 12v and 5v. That makes 17 if they're both negative. And -5 and -4 make +20. All right, over here, no GCF, so 7a and a. With my 4 in the back, I think I will try 4 and 1. So that makes 7a and 4a, which makes my 11 if everything's positive. All right, this next one. So these numbers are pretty big. Also have these m's everywhere. So that kind of indicates to me I'm going to take out a GCF. So 1m can come out, and let's see, I think these all divide by 2, not 3 or 6. Okay, so take a 2m out, which leaves me with 3m squared minus 20m minus 7. So that looks all nice and clean, no GCF left. So that 2m stays, and then I work on this part. So 3m and m. So I think if I do 7 and 1, because see then look here, this is going to be 21 and 1. So if I make my 21 negative and my 1 positive, that'll give me my -20. So negative and positive. All right, over here, 8, 4, and 60 all divide by 4. Yep, by 4. They do 2, but 4 is better. And they don't all divide by 8. So I'm going to take a 4 out, which leaves me 2v squared plus v minus 15. All right, so 4 got 2v and v. My signs are going to be different because it's a negative 15 in the back, so I just don't know where they go yet. Let's use 5 and 3. So if I put 5 here and 3 there, you see how that's going to be a 6v and a 5v. If I make my 6 positive and my 5 negative, then that'll be a positive 1. So this one's positive and negative, and we are done. All right, that's good. So now you go and do this page, and good luck. Bye-bye.